Good evening. Today I want to teach you the first, call it strategy number one, strategy for calculating slope, the unit rate strategy. So if you would, please make this title on the next free page in that math notebook. You've done that, clear those distractions, and be ready to go. Okay, so we talked in the last lesson about what the word slope means. It's a measurement of how steep a linear graph is. So a measurement means we're going to start to assign a number to it. We haven't done that so far. The measurement of how steep a linear graph is. So we talked about in graphs like this line, for instance, is steeper. This person would be traveling higher slope. So when we calculate it today, this is going to be a greater number than, say, this one, which is more gradual. This person is moving slower away from wherever they're moving away from. This is going to have a lower slope when we calculate it today. So we found these two slopes. This one will be greater, this one will be less. And we also talked about even slope on intervals. This interval here has a slope that is more gradual than, say, this one. It's moving away faster here. This is steeper or a higher slope. This has still, we would say, has a slope. It has a slope of 0 when we calculate it. And these are all like where this distance is getting farther. We would say this has a positive slope. This has a positive slope. Here, when we trend back down to the beginning, we're going to say that has a negative slope. We're not going to get into that today. But there's all kind of things in that direction. We've also talked about unit rates many times in the past. Unit rate is a ratio where one of the two things in the ratio is a 1. And in particular, we're going to stick with y to x ratios. And our unit rates are always going to be where the x is 1. So where we go 1 on the x-axis. So when we talk about unit rates there, here, so we're going to be talking about that, like the time in 1 year or the time in 1 hour. We're going to be talking about unit rates like that as we find slope today. So here we go. So the first strategy for finding slope is to calculate how much y increases each time x increases by 1. This is just that on the last slide. X increases by 1. We're going to find a y to x ratio and where the x is 1. So in this case, this is essentially the same as finding the unit rate. So we're going to be looking at here miles per hour, per 1 hour. So what we're going to be calculating. If we find that unit rate, that's going to be the same as the slope of this graph. So it's tricky on this one to find, but we can do it. So we want to know how much does the distance increase each time 1 hour passes. So kind of tricky here because we don't see it in ones, but what I do see is in 5 hours, which is not what I want, up we go by 5 miles. And then the next one, to go another 5 hours, we go another, did I count that right? It's 6, I'm so sorry. It's 6. We go up 6 miles. In 5 hours, we go up 6 miles every time. Every time the hours goes up by 5, this is hours, remember, on the x, and distance is on the y. The distance goes up by 6. So I don't see my unit rate yet, but I do see 6 miles every 5 hours. So my question is, how many miles every 1 hour? That's going to be my slope. That's how far in 1 hour. You're not going to be able to tell from it looking here, but we're going to see in 1 hour, which would be only this little bit, how far do we go each time we go 1 hour. So I'm just going to use an old ratio strategy to do that. If I divide my hours by 5, then I divide my miles by 5. And 6 divided by 5 is 1.2. So in this case, the person is going 1.2 miles each hour, right? If you do that 5 times, you would get to here. And so we would say the line has a slope of 1.2. So that's it. If you can find that unit rate, you've got it. Now, in a proportional relationship, which this is, that's easy to do here, can be a little bit different when we don't have a proportional relationship. Here, we're not starting at 0, 0. We're starting up here at 0. Let's see if that's 8. That'd be 12. So we're starting probably at 10, right? So same thing, finding slope, which is what we're going to calculate. What's the slope? Is how much does y increase each time x increases by 1? What's the unit rate? When we go 1 year, this has 10 years. When we go 1 year, how much does the tree grow? 1 year grows how much? 1 year grows how much? 1 year grows how much? That's what we want to figure out. That's the slope. How much does it increase in inches, which is y, each time 1 year passes? Okay, so we want that. We want to know each time x increases by 1. This is finding the unit rate. So in 1 year, how much does this tree grow? So I can't, again, this goes by 5, so I can't obviously look at this and see how far it goes in 1, so I'm going to have to do some thinking here. So what I can see is this starts at 10, so when x increases by 10 years, looks like this increases by 4 inches. 10 years, 4 inches. 10 more years, 4 more inches. So it is growing at a steady rate of 10 inches, 4 inches every 10 years. That's where we are so far, 4 inches every 10 years. My question to find the slope is how far does it grow in 1 year? Same thing as last time, I'm going to use an old rate strategy. Just divide by 10. Divide by 10, and it grows about 4/10 of an inch per year. So this tree grows that much each year. That is a unit rate each 1 year. So I would say that that is my slope. So the slope is 4/10, 0.4. Okay, that's how you do it from graphs. Tables all works the same way. We don't see the graph, but it's the same deal. We want to know how much does y increase each time x increases by 1. So remember, x is always going to be here. Y is always going to be here. So we're looking at the number of rolls per case of paper towels, right? So that's a unit rate. And we want to know each time the x, which is cases, so by 1 more case, how many more rolls? That's the y, number of rolls. So we want to know each time you buy 1 more case, how many more rolls do you get? So again, not super easy to see, but we want to see each time we go up by 1 case, how many more rolls? So we don't see that on here. We see 2, right? So if you do this twice, you go up by 24 cases. So it looks like if you did it once, you would go up half that far. So we could even squeeze in here 224, 336. 1 more would be 12 more. 1 more, 12 more, 1 more, 12 more. So it looks like each time you buy 1 more case, you get 12 more rolls. No even more extra math to do here. This one worked out pretty good where I can just see the rolls. So here you get 12 rolls per case. So if I graphed this, which I'm not going to do, each time we did 1 case, we go up 12 rolls. 1 more case, 12 more rolls. Excuse me, and we'd have a slope of 12. Each time you went over 1, you'd go up 12. Over 1, up 12. That's the slope. How far do you go up each time you go over 1 on the x? Last important note before we get to WeDo, only linear graphs have slopes. Until you get to calculus down the road, we would not say that there's a slope here because you'll notice like if you go over 1 here, you go up a lot. If you go over 1 here, you go up a little. It's not the same. So we don't have a slope. We just don't say a curve has a slope. Same here, inconsistent. Here, when you go up 1, you go up 8. Here, when you go up 1, you go up 24. Here, when you go up 1, you go up a lot, 70 something. And again, no slope. You've got to have a linear graph and equal increments to have a slope. All right, open your math notebook and we'll start with this one. The first strategy for finding slope is to calculate how much y increases each time x increases by 1. So we're going to stick with this y to x ratio. In this case, the y is gallons and the x is minutes. So we're looking for how much does the gallons increase each time the minutes go up by 1. So 1 more minute, how many more gallons? 1 more minute, how many more gallons? 1 more minute, how many more gallons? This one's easier to tell than some of those last ones I did, which is super nice. I'm going to expand this graph a little bigger so I can write on it better. And this is pretty easy to tell, right? You go over 1 more minute, you go up 5 more gallons. 1 more minute, 5 more gallons. 1 more minute, 5 more gallons. So each time 1 minute passes, you go up 5 gallons. It's a 5 to 1 ratio. 5 gallons per minute. And so we have a slope of 5. That's how steep this is. Each time you go over 1, you go up 5. That's the slope. If you want to even write that in. That's what we're looking for. We can still do it if it's not a proportional relationship. This is not a proportional relationship because we don't start at 0, 0. But we can still do this. So we want the y to x ratio. In this case, x is days, y is pages. And so we want each time x increased by 1, 1 more day, how many more pages? 1 more day, how many more pages? 1 more day, how many more pages? Let's see. Up here. So we start at 40. 1 more day looks like we do 30 more pages. 1 more day, 30 more pages. 1 more day, 30 more pages. So each time days goes up by 1, pages goes up by 30. That's 30 pages per day, which means we have a slope of 30 on that graph. Slope of 30. Each time we go over 1 day, we go up 30 pages. That is what slope means. Okay. Works on tables as well. This is always my x, this is always my y. We want the y to x ratio. In this case, x is mules, y is bales, and so we want how many, 1 mule is how many more bales, right? And you'll notice this is not too bad to do. Here we go up by 2s, not by 1. 2 more mules, 1 more bale. 2 more mules, 1 more bale. So we kind of have to imagine those in between values. So if we went up by 1, we'd go up by a half, 1.5. Go up by 1, go up by a half. So it looks like to only go up 1 mule, 1 on the x, that's what we want. We would go up half on the y. So that's half a bale per mule. And that is the slope. If we graphed it, which I don't want to do, each time we went over 1 mule, we would go up half a bale of hay, because each one needs half a 1. That is called the slope. Okay. Last little note, only linear graphs have slopes. So we would just not say this, just like you don't, it's not that it has a slope of 0, it just doesn't have a slope. We wouldn't calculate slope here. We wouldn't calculate slope here. It's not linear. Slope is a feature of lines and lines alone. A lot of information, y'all. I hope it made a lot of sense. I tried to show a lot of different situations. If you need to give this another go to feel confident before class tomorrow, please do, because I would love for you to show up feeling great, and I'll see you then.